Hi everybody. In today's video, we're going to talk about solving systems of equations, how to do so, and also how to check your work and to get your final answer. You may have seen system of equations before, which is just giving you two or more equations to help define a certain solution. So for this case, we're given two equations that helps define one solution. And the important thing to know about a system of equations, especially with y is equal to 3x plus 6 or y is equal to 2x plus 10, these two things are just lines. And the solution will be the intersection between these lines as well. So in the case of two arbitrary lines or two lines that don't match these equations over here, if we had this line here and this line here, the solution between these two equations is going to be the coordinates of the intersection. So let's keep that in mind. So if you're really good at graphing, you can graph these two lines and find that intersection, or we can mathematically solve for it. The way that we mathematically solve for it is that we want to cancel out one variable while retaining the other to help find that solution. And the way that you can do that is basically by manipulating the equations, adding them together in order to cancel out something. So in this case, we have y and y on the left side of both of them. So let's say we want to add these equations together, the left sides together and the right sides together, but also in the negative form. So actually, we're essentially subtracting the second equation from the first equation. We can do that because what we're doing to the left side, we're doing to the right side, just in a different form. So in this case, we're going to get y minus y. If I'm writing everything explicitly out, we're going to get 3x plus 6 minus 2x minus 10. And whenever you combine like terms with the x's and the x's, the y's and the y's, and the constants together, you're going to get 0 on the left side is equal to x minus 4. And this is very easy at this point, where if you add 4 to both sides, you're going to get x is equal to 4. So for in this case, we've done everything the problem has told us to do, which is just solve for x. But if you want to find the exact solution or the xy coordinate, what you need to do to solve for y is that you need to plug in your x for either line. It does not matter if you do line 1 or line 2. And I'll show that here within the problem. You'll get the same y for either answer. So if we call the first one line 1 and plug in x is equal to 4 for that case, y is going to be equal to 3 times 4 plus 6. And if you end up doing that, you end up getting 18 for line 1. If you do line 2 and you plug in x is equal to 4, you're going to get y is going to be equal to 2 times 4 plus 10 is equal to 18. You get the same y coordinate for either line when you plug in that specific x equation. And that's because it is the intersection between these two lines. So the full solution is the xy coordinate points or corresponding to x is equal to 4 and y is equal to 18. So that is your solution between these two specific lines. So let's take that information and let's move on to some harder problems with the idea of solving system of equations. And later in this video, we're going to be working on word problems and actually building these equations. So for this problem, we're going to do the exact same thing as we did before in the last problem. We're going to try to find the xy point where these two lines intersect. So in this case, it is essentially the same thing as solving for the system of equations. So the idea is now try to figure out a way to add and manipulate these equations in order to cancel out either x or y and retain the other. And what I really like about this specific equation, if you multiply the 3x equation by 5, you'll get 15x for both of them. So let's end up doing that for this case. So if you do 15x plus 7, or your second equation, I'm just going to bring it down. And if we multiply everything in the first equation by 5, we can subtract that equation from the second one. So 15x, because we multiplied it by 5, plus 35 is equal to 10y. If we subtract this equation from the one that we brought down, we'll end up with 0x. So we're not even going to write it in. And we do 7 minus 35 is equal to y plus 2 minus 10y. And if we combine like terms, we're going to get negative 28 is equal to negative 9y plus 2. And then we subtract 2 over on both sides, so we get negative 30 is equal to negative 9y. And so y is equal to 30 divided by 9. This is the y part of the solution. So now we need to find the x part of the solution. And again, if you're worried about if you find the wrong value for y, if you plug this value for y in for both these lines and you get different answers, then that is not the correct y part of the solution. So let's look at the first equation, or line 1, I'm going to call it. So let's plug in y is equal to 30 over 9. So we're going to get 3x plus 7, go to 2, times 30, divided by 9. So if we do 3x plus 7 is equal to 60 divided by 9, or we have to go further here, 3x is equal to 60 divided by 9 minus 7. We're going to multiply 7 by 9 in order to get them to be looking nicer to each other. 60 over 9 minus 63 divided by 9, because that's the same thing as saying 7. And now we combine like terms again. 3x is equal to negative 3 over 9, or x is equal to negative 1/9. I recommend practicing solving equations. If you end up with more practice and practice, you can end up going step by step without questioning what you need to end up doing. But that's for line 1. Line 2, let's do the same thing. We're going to plug in 30 over 9 for y. So we have 15x plus 7 is equal to 30 over 9 plus 2. And so let's combine like terms. 15x is equal to 30 over 9, and I'm going to subtract 7 from the 2. So we're going to get negative 5. So 15x is equal to 30 over 9 minus 45 over 9, which is the same thing as saying 5. 15x is equal to negative 15 over 9. And if you divide by 15 on both sides, you're going to get x is equal to negative 1/9. So the same x part of the solution as before is in line 1. So this is the correct solution. So the xy coordinate solution, or the point where they intersect, is going to be negative 1/9 for x and 30 over 9 for y. Let's move on to some word problems where we actually have to build the equation up ourselves. For this problem here, a shopper wants to buy apples and oranges with 23 coins. If an apple costs 1 coin and an orange costs 2 coins, and they only have enough space in their bag for 15 pieces of fruit, how many apples and oranges can they even buy? So here is the idea of a system of equations to figure out how much apples you can buy and how many oranges you can buy with 2 different constraints or 2 different equations. So the first equation that we have to think about is the money piece, where we have a total of 23 coins, and the amount of coins that we actually have to spend is the idea that an apple costs 1 coin, so we're going to call it A, or 1A. So every apple that you buy is just going to be 1, so it's going to be 1 times A. And an orange costs 2 coins. And I'm going to call oranges R. So oranges is going to be equal to R. Apples is equal to A. A plus 2R is equal to 23. That's our first equation. Our second equation is about the amount of space that we can actually end up storing this in. And that's going to be the idea that all your apples plus all of your oranges have to add up to be around 15 at the very most. In this case, we're going to say they buy enough to fill up their bag completely. So these actually 2 equations give us everything we need to actually solve for them. So let me bring over the 23 here. And now let's just subtract the second equation from the first one to get rid of the A term. And if we subtract the second equation from the first one, we're going to get 0A, and we're going to get 2R minus R. I'm still going to write everything in for now. We're going to get 23 minus 15 on the right side. And so we're going to get R is equal to 8. So we're going to have to be able to find 8 oranges. And now let's just plug this back into the second line, where the amount of apples plus oranges have to be 15. So we know the number of apples have to be equal to 7. From line 2, very easily. And if we go back to line 1, just to check ourselves, if we plug in 8 for R, we're going to get A plus 2 times 8 is equal to 23. And if we solve for a here, we're going to get a plus 16 is equal to 23, or a is equal to 7. Same solution for both lines. So we know we had the right solution for oranges. So we can get 8 oranges and 7 apples using the system of equation method. In a later video in advanced equation solving, in some cases there will be no solutions, or some cases there will be infinitely many solutions, but not here. Let's go to this last problem where we're going to actually have 3 different constraints and 3 variables. So in this case, there are a total of 9 dice in a bag with 3 different colors of blue, red, and orange. There are twice as many blue dice than red dice, and there is 1 more orange dice than red die. How many of each color is in this bag? So let's go through it and give ourselves a variable name for each of these colors. So for blue, I'm going to call it B, or capital B. Red, it's going to be capital R. And orange, and not as simple as before, we can define it to be whatever we want, but let's give orange to be an O with a little line in the middle. This is actually a Greek letter theta. We'll use it for this case. So let's make our different constraints that we have. We know there is 9 dice total in the bag with 3 different colors, so we have to know the number of blue dice plus the number of red dice, and the number of orange dice have to equal to be 9. That's our first constraint, or bro, is equal to 9. In the next constraint, there is twice as many blue dice than red dice. So that means blue has to be equal to 2 times the amount of red dice, or 2 times R. So this is our second constraint. And if you get confused about which one you have to multiply by 2, blue is going to be 2 times the amount of red, so that's how we read the equation. Blue is equal to twice as many red dice. And the same thing for the next one. There is 1 more orange dice than red dice. So for orange, there is 1 more orange dice than red dice. Or here, this equation reads orange is equal to red plus 1 dice. Same statement that we have. So here, we have 3 different constraints, which mean there'll be exactly 1 solution for all of these variables. So let's go through and figure out a good way to solve for all of these. Now, if the adding method is a little bit not as easy, you can end up substituting these things in for b and theta in order to get everything in terms of r. So let's do just that. We know b is equal to 2r, so let's plug that in for the first equation. So that's what we're looking at. B is equal to 2r, so we're going to do 2 times r plus r, where we'll keep track that this is just the same thing as saying b. And now we know theta is r plus 1, so let's plug that in for theta as well. R plus 1 is equal to 9, where this is the same thing as saying theta, or oranges, or orange dice. Now, the adding equation method you could technically do here. You could also do the substitution method as well. It just depends on however you like to practice it and however it makes sense to you. So now let's combine our r terms, where we have 4 different r terms. We're going to have 4r plus 1 is equal to 9, where we get 4r is equal to 8 after you subtract 1 to both sides. And so there's 2 red dice in this specific bag. So we have one part of our solution. We have r is equal to 2, which I kept track of in the top right corner. Now, there should be certain equations that will make it very easy to solve for blue and theta, or combination of the two if you have to do another addition of the equation. But if you look at just blue and theta, blue is equal to 2 times r, so r is equal to 2. So there has to be actually 4 dice just in the blue bag, or there has to be 4 blue dice in this bag. And we know all of the dice add up to be 9, so we plug in b and r into the first equations. We can see that there has to be 3 orange dice in here as well. Or if you end up plugging in r for theta for the last equation, you'll get theta is equal to 3 as well. So we know that there is 4 blue dice, 2 red dice, and 3 orange dice. I hope you have learned something today. please check out my channel for more chemistry and math practice problems, and have a great day.